higher education and the industrial partners as well. Now, Szengine Varga, the team captain of Szengine engine development team, will speak about what has happened on the non-technical side, and after that, Kari Istvánko, the construction leader of the team, will introduce this engine.
Yes, thank you. Dear guests, first of all, let me say a big thank you to our main sponsors for their support throughout the whole year. Please come forward to receive your award after your name is called. Fanny, please help me. Yes, from the Audi Hungary, Johan Mendel, please come here. I would like to give you a present. Thank you for this help. Marketing, of course. After that, Mr. Péter Földesi, please. Thank you for the support and the university's support. Of course, Mr. Borna Hanula, please. Thank you for your stories and everybody's everything. I could say everything. Yes, after that, a German paper to Mr. Kai Schinzer. Vielen Dank, Mr. Schinzer.
Sehr gerne.
Thank you very much. Yes, of the Academy, please, if I'm not mistaken, yes, Péter Eliás from the Audi Academy. Please come here. Thank you for the trainings and workshops. Yes, Béla Rákóczi, please come here from the Tenshit Ltd. Because thank you for your support. Without your company, we couldn't stand here and the engine couldn't be here. Thank you. Yes, from ABL, Mr. Dirk Janecko, please. Thank you to the workshops. Mr. Daniel Várnagy from X-Meditor. Yes, thank you for all your support. The webpage, our flyers, and so on and so on. And last but not least, Mr. Lórány Csergő, please come here to the stage. Thanks for your help to the test bench. Thanks a lot. So as I mentioned, we couldn't stand here without the support. Yes, what happened to us since the rollout last year? I think the most important thing is that we are here today. What does it mean? We successfully observed what we promised in 2012. As you can remember, we will meet next year at this place with the second generation engine. It's no surprise that there is an engine under this veil. It means that we picked the yearly cycle up. In the last year, we had to learn how we could focus on more things at the same time. I mean, we made a lot of tests with the first generation. During these tests, we manufactured the second generation, and from the beginning of September, we are working on the third generation too. You could see that a lot of things have happened, so I would like to highlight some of them. Thanks to our sponsors, we took part in many workshops and trainings, as I mentioned. These events provided not just the project's development, but the student skills too. Everybody knows that Formula Student means a student project, So the good connection and the motivation between the team members is very important. There was a motivational event when we planted this tree called Szengine tree, which is a great metaphor for the whole project. As the Japanese tulip tree blooms in each year, the Szengine team creates something new, something lasting in each year. After the rollout in 2012, we had to work a lot until we could start the first generation. We prepared the building to the tests, we applicated the engine to the test bench. It was in winter, and you could see that we didn't afraid of the cold weather. We didn't sleep, we worked a lot until mornings, but when we could hear the engine's noise, it was an unforgettable event for the whole team. It gave the biggest motivation for us, for the teammates. We could clearly remember that the engine had started at 1:30 in the night. There was an important evening also in spring called Formula Student Engine Symposium. We heard a lot of technical presentations which were very useful for us. But we had the opportunity to show our work to other Formula student teams. We held a presentation and everybody could see our engine after some tests at the test bench. The result of this event that our development is heading to the right way and there is a great demand for a unique engine in Formula Student series. More and more people are interested in our project, follow the team's daily life. We have reached more than 10,000 people with our web page. I would like to highlight some of them because we couldn't stand here without them, of course. For example, the leaders of our university, the leaders of our main sponsors. And this year we had the opportunity to meet with the Prime Minister of Hungary. We gave a team shirt to him as a souvenir, of course. We are not just working people in the team, we are friends too. The sport has a good effect on the teamwork and it helps the common cooperation. There were a lot of football games during the summer between the Department of Internal Combustion Engines and the Szengine team. Of course the result is a draw, but to be continued in spring. Of course we need to relax sometimes. We try to spend our free time actively, what remains after a lot of work. This picture was taken at Eto versus Bayern München football match. It was exciting, but we realized that we have to learn a lot to reach this level. The team's next big event was the Formula Student Hungary, which took place this year 4 times in a row. This is the most important event of the Hungarian Formula Student life. We could proudly stand near a ready engine and met our sponsors from the industry and from the university as well. Last year we had only some parts, but in this time, as I mentioned, we had the whole engine. It's a good opportunity to get the feedback from our sponsors. They could show what we have done in the last month. Yes, teams came from all over the world and they are waiting for a competitive race engine. That's why we are working a lot and that's why we would like to reach our goals. But for more details, you should wait a little bit. One of the most important things in the life of the team is to ensure the supply. You should think about the future, about the next generation. We are not in an easy situation because when somebody gets the hang of the teamwork, he is in the industry with one foot. Fortunately, we have a lot of students who are interested in our project. We organize the freshmen's event in each year. After that we are teaching them and we could give more and more tasks to the freshmen. I think it's necessary to ensure the continuity of the project. If we would like to be the first engine supplier in the Formula Student series, we must think about it. I could say proudly that we are on the right way. Thank you for your attention. Please let me introduce Károly Istvánko, who will speak about the second generation engine.
Thank you very much. My name is Károly Istvánko, and I am the construction leader of the Szengine engine development team. In the next minutes, I would like to speak about our activity in the last year since the first engine rollout. After the introduction of the first engine, we began to work hard on the second generation. Our main aims were to reduce static and the dynamic messes. Is the most important at racing engines. And we have to increase trustworthy because the hugest experience in a Formula Student event is the long distance racing, the endurance. Here you can see the first generation of the engine, which contains 258 parts, and 70 were unique from that. And the total weight was 32 kilograms. And here you can see the second generation. It contains 296 parts, 93 is modified from the first engine, and the total weight is 26 kilograms. After the manufacturing of the first generation engine, it was important to compare our models with the manufacturer-ready parts and to see the physical behavior of these pieces. On the picture you can see flow bench measurements, which has significance at the modifications of the cylinder head and the fuel injection in the future. During our measurements, we had several help from the measuring laboratory in all cases. As you can see on the picture on the left side, our teammates not just design the parts, but they do the assembly as well. All the parts has been verified from different sides, not just the physical sizes, but if we had opportunity, we made microscopic monitorings as well. The assembly of the engine was parallel with several mechanical measurements because of the opportunity of the mistakes of the tolerances of the parts. When we could solve all of the mistakes of the manufacturing, we made the adjustment of the engine and we became ready for the first step as the test bench. The application for the device is not so easy because the one-cylinder engines are so imbalanced and it caused several problems. And this was the beginning of the most exciting hours, I suppose. It's important thing from my side that our test bench is a self-developed one, which is made by the team members as well. It's always good to see the teamwork if we have to make a safety wall or just to paint out the room. The next pictures will be shocking, I think. As you can see, in the last year we had several experiences, and I suppose Mr. Barnahona describes it on the best way. He told, at the first time you were looking for me because of simple problems, which are typically amateur ones, but later you had good mistakes, which are so common at the engine development firms as well. We learned so much from the tests, like the foaming of the oil, the broken spark plug, or the imprecise cylinder head sealing. On one hand, we had fortune several times. For example, when a 35mm long screw was fallen into the combustion chamber, but nothing has happened. But on the other hand, we had bad failures, which has been put off as like a broken airbox. We realized our engine specialties, like the imbalanceness of the engine, which occurs high stress at the turning masses, as you can see on the flywheel over there. Or some construction devices as well. For example, the underdimensioned chain drive, which occurs chain brake at turning engine. But at the end, everything turns good, and for this result, it's worth to work a lot. But after the first generation engine, we did not have a rest, and we began working on the second generation and the connecting systems as well. We designed and built a unique telemetry system, especially for the requirements of the Formula student. The ECU sends the data for the telemetry, which transmit them to the box for the teammates, and it's going in real time, and we have the opportunity to monitor the data at more pieces at the same time. Here you can see the circuit diagrams of the device. The hardware has opportunity for future development. For example, we have chance for the vehicle sensors parameters transfer. At the moment, the system can transfer 15 signs from the engine, and you can monitor it with our own development telemetry software. At the test, we have reliable communication within 1 kilometer. This is fully reliable considering the sizes of a formal student racing track. Here you can see the ready system. After the first generation engine, we began to design the crankshaft of the EVo2. Here we have the purpose to optimize for racing use only. It means the mass reduction and the maximal stiffness. The fourth model here is the EVo1 crankshaft. The second and the third are stuffed between the new and the old constructions. We have several rejected parts till we reached the ready version. The last one is the actual model, over here. As you can see, this is not a so common three-parted crankshaft, but it's full of design curiosity. For example, that wall over there, which is very important part in connection with stress reduction. The mass adjustment is made by the GT crank software. We don't use balance shaft because of the racing purpose. The turning mass forces could be adjusted in 100%, the alternating mass forces in 50%. The first diagram is a polar graph where you can see that the maximal forces, 40%, is the mass forces. It's here. The second picture shows the X and the Y orientation forces. For the DEG irregularities design, we use alpha excite. This effect has several negative influences for the chain drive or the valve train as well. At the new construction, the main purpose was the mass and the stiffness. The next video shows a stress distribution of a new mechanism in one whole cycle through 720 degrees. The new mechanism is looking like this. The most important thing is the streamlined design, because this can reduce waste energy over here. The EVo2 crankshaft's final geometry is nearly 18% lighter than it was before. The chain drive and the oil pumps drive is modified compared to the EVo1 as well. The chain drive is more stressful because of the problems I mentioned previously, and the oil pumps drive became easier than it was. From the side of cheapness, these modified parts are all from the market. And now, I would like to introduce the new crankcase. The purpose was the same like at other parts: mass reduction, reliability, and stiffness. The takeoff part is the EVo1. The stress simulations are made with the help of the first generation. On the left picture, you can see the stress distribution. The blue color indicates the low stress areas. The right one is a Tosca structure optimization. The blue places are not important from the side of loads. Here you can see how does a part born from analysis. One interesting place is the front over here, where we reduce this weight, which is not so obvious, without any kind of simulations. And here are some important data about the crankcase. The start weight was 9.6 kilograms, and we got for 6.5 kilograms. This is 3.1 kilogram rest reduction, which is 33%. Here you can see an exploded view from the part. The unloaded chain drive cover is made by polyamide 6.6, which is lighter than the aluminum. The loaded parts are from aluminum, which is stiffer and lighter from the feathers. In the next some slides, I will speak about the cylinder head and the development around it. These pictures show the previously mentioned flow bench measurements result. The first graph is the 90 mm diameter throttle flow coefficient geared to the throttle opening in percent. It's here. The second graph is the cylinder head coefficient geared to the valve lifting in millimeter. This helps to set the valve train characteristics. It's over there. The modification of the cylinder head had not so wide range because of the ready casted part. We had opportunity just to change the molding manufacturing of the ready part. The red places shows where we shifted up the surface because of construction sites. The blue places shows where we remove material because of higher valve lifting. Here you can see how could we rebuild the valve train of the modified cylinder head. The main part is the double valve spring, which helps to avoid the resonance frequencies. Here you can see the relatively long and heavy valves, and because of that, the valve train design is a difficult task for the team. In the Formula Student, the fuel consumption and the maximal power is very important, so we spent time with the optimization of the fuel injection. After several variations, we have the best one, which guarantees the maximal performance. I have just reached the end of my presentation, but I have one more task. Please let me proudly present, after 371 days and 1,000 hours spent with the hard work, the result of the last year, the next generation Szengine EVo2 engine.
Thank you very much for the applause, and yeah, and special thanks for the musicians of Varga Tibor Institute of Musical Art. Thank you. And I invite you to an informal conversation, and you can find some freshmen near the entrance. If you have any question, just feel free to ask the red-shirted teammates here. And thank you for being here today, and thank you for your support during the whole year. You will hear about us again.